In this lesson, we do some work on rectilinear motion. I'm going to look at a couple of new formulas for acceleration. The first one, acceleration equals d dx of half v squared. And the next one, acceleration equals v times dv dx. So those two new formulae, you need to remember them very well. The first example, we need to show that d squared x dt squared can be written as v dv dx. Okay, in other words, we're proving one of these acceleration results. The solution then, let's have a look at it. We'll start with d squared x dt squared. Now we can rearrange that d squared x dt squared. We can write it as d dt of dx dt. Well, if we think about it, we've got d dx, and that's why we get d squared x. And on the bottom, dt times dt is actually dt squared. Okay, that's a little bit of notation there. Now, what have we got? Well, dx dt is in fact the velocity. Okay, that's the velocity, change in x over change in t. That is velocity. So we've got d dt of v, which we write as dv dt. Okay. At this point then, a little bit of something that you'll need to just learn what to do, because it's not that obvious. And we're going to write that as dx dt times dv dx. Okay, so that little step there you'll need to learn off by heart. Let's see why we can do that. Basically, look at those dx's, they would cancel, and you can see that, yes, we would have dv over dt, okay, than what we had the line above. Okay. All right, so what have we got? dx dt, well, that's our regular velocity formula, isn't it? Okay, v, and dv dx, we'll write that down, and that is exactly what we were trying to show. All right, we showed that the acceleration equals v dv dx as required. Terrific. The next example, a particle moves in a straight line such that its velocity is given by v equals the square root of 4x plus 1, where x is the displacement in meters from the origin O and t is the time in seconds. Initially, the particle has velocity 3 meters per second, and we're asked to find an expression for x in terms of t. Okay, let's consider the solution then. Let's start with writing down our velocity formula, v equals square root of 4x plus 1. Now, we'll use this acceleration because if you look at it, it's got d dx of half v squared. So acceleration equals d dx of half v squared. So that equals the d dx of, now, a half, let's write that down, v squared, well, if v equals the square root of 4x plus 1, once we square it, let's get rid of that square root sign, we just get 4x plus 1. And that can simplify to be d dx of, well, a half of 4x plus 1 is 2x plus a half. Okay, we haven't found the derivative yet, we've just rewritten it. Now let's find the derivative. So d dx of 2x, well, that is simply 2. And the derivative of a half, well, is just nothing, so let's ignore that. So at this point, what have we got? We've now got the acceleration equals 2. We can therefore write dv dt equals 2. And the reason we've written that is because we need to find an expression for x in terms of t. So hence we brought in dv dt. Okay, so we need to integrate. Okay, we integrate that. We end up getting that v equals, now the integral of 2 is 2t. And don't forget we must write plus c, the constant of integration, which we will find in a moment. So initially, the particle has velocity 3 meters per second. In other words, when t is 0, the velocity is 3. So applying those conditions to our equation above, we end up getting that 3 is equal to c. So we've got our velocity equation. We now know the value of c, so therefore we get that v equals 2t plus 3. At this point, we still need to get an expression for x, so we're nearly there. We need to use our velocity equation and we need to integrate again. So we integrate velocity, we end up getting that x equals the integral of 2t, simply is t squared. The integral of 3 is 3t. And don't forget our constant of integration. I've used a k this time just to indicate it's not the same c as above. Now what else we've got? We're told initially the particle has velocity 3 meters a second. So initially v equals 3. But where are we going to put that? We're going to put that way back in the original velocity equation. So if v equals 3, we end up getting that the square root of 4x plus 1 equals 3. Now to get rid of the square root, let's square it. We need to square both sides. We end up getting that 4x plus 1 is equal to 9. And solving that, take the 1 over. subtract it, we get 4x equals 8, and solving that, therefore, x equals 2. Now that x equals 2 was the initial condition, in other words, when t is 0. So we now then can say when t is 0, x equals 2, and substituting that information into this particular equation, we can therefore find that 2 is equal to k. So we've got that equation for x. We now know the value of k. So let's substitute the value of k in. Therefore we get that x equals t squared plus 3t plus 2. And that's our final answer. Terrific.